All right, so today we're going to work on a second day of lesson 6.5, graphing inequalities in two variables. Yesterday we really looked at how to create the graphs, how to get it in slope-intercept form, use the slope, the intercept to create the boundary line, and then determine whether that should be dashed or solid or shade above below. Today we're going to look at some other aspects of it. And the first one is to be given a linear inequality like this, determine if a group of answers, or if any one of these ordered pairs, I should say, are answers to this inequality. Now, one way to do this would be to take this, this two variable inequality, solve it for y like we did yesterday, create a graph, shade above, below, and then plot the points and see where they lie. Are they in the shaded area or are they not? That's one way you can do it. A second way to do it is a little bit more um, maybe direct, and that is go ahead and take your ordered pairs and plug them in and see if it makes it true or false. So, for example, I'm going to take the inequality 7x minus 4y greater than or equal to 18, and I'm going to put in the ordered pair 4, -1. So I'm going to replace x with 4 and the y with -1. If this point is a solution, then this will be true when I'm done. So 7 times 4 is 28. -4 times -1 is +4. 28 plus 4 is 32. Now, true or false? Is 32 greater than or equal to 18? Yeah, it's true. So the point for -1 is a solution. And if you were to graph it, it would be in the shaded part. Okay. So we'll just keep on checking them this way. So is the ordered pair 8, 9 a solution? Well, again, put 8 in place of x, substitute 9 in place of y, see if it works. So 7 times 8, 56. 4 times 9, 36. Subtract. We get 20 is greater than or equal to 18. True. So 8, 9 is in the shaded region. Check our next point, -3, 0. -3 in place of x, 0 in place of y. Simplify this. 7 times -3, -21. 4 times 0, 0. We're going to get -21 is greater than or equal to 18. That is false. So that is not a solution. And then finally, our last point is -2, -8. So let's put -2 in place of x, -8 in place of y. Simplify. 7 times -2 is -14. -4 times -8 is +32. -14 plus 32 is 18. Is 18 greater than or equal to 18? Yes, it's equal to. So that counts. So this point is a solution. And what this point represents is a point that's on that boundary line. Because the two sides were equal, that tells us it was on the boundary line, and because of the equal to part of my inequality, that makes it true. Okay, so you're going to get some that deal with these tonight. All right. Uh, a second part of this concept is that let's go ahead and work on the problems we did yesterday, but let's do it looking at horizontal and vertical boundary lines. Okay, so we're gonna, how would I graph this as if it was a two variable system in the XY coordinate plane? All right, well, our process stays the same. So step one is to write the inequality in slope intercept form. We don't have to do that. We know that x is less than, x being less than -3, that graph is really that of the line x equals 3. X equals 3 is a vertical line that goes through the x-axis. So that should be at -3. Okay, so when I put an equal sign in here, that tells me it's really the graph x equals -3. Sorry, those both should be negative. All right, so I know what the boundary line looks like. It's a vertical line that goes through the x-axis at -3. The slope for any vertical line is undefined. It doesn't have a y-intercept because it never goes through the y-axis. So those two really don't do anything for us. Okay. Should it be dashed or solid? Well, that inequality is just less than. That means it's dashed. Okay. Should we shade above or below? Well, that's kind of, if you think about it, if our line is vertical, there really is no above or below, right? Because it's a vertical line, there's really no above or below. So we got to look at it as, the less than is going to tell us to shade to the left because The numbers that are less than -3 are the ones that to the left on the x-axis. So I'm going to wind up shading to the left here rather than above below. Okay, let's take a look at what we're saying. So here's our graph. We knew that x equals -3 is a vertical line that goes through the x-axis at -3. It's dashed because of the less than symbol. And we're going to shade to the left because think of the x-axis just as an x number line. All right, the numbers to the left of -3 are all the ones that are less than -3. So here's my graph. Okay. The fact that we get a vertical horizontal boundary line cuts out a little bit of work here, and we still finish it the same way. Okay. Let's look at another one. So this one is y is less than -7. We're going to treat it like a two variable equation, one that we can put on an XY axis. So the first step is, it says write the inequality in slope intercept form, right? That's what we've done. Do we really need to do that here? No. Y is less than -7 really represents the line y equals -7, which we know is a horizontal line that goes through the y axis at -7. So I know what the boundary line looks like. It's a horizontal line that goes through the y axis at -7. Now, should that boundary line, or actually, let me back her up. What does that mean? The slope is 0. The y-intercept is obviously -7 because we're going through the y-axis at -7. We really don't need these two. I just kept them in there just because, I want to make sure we're all on the same page here. Second step, should it be dashed or solid? Well, less than says dashed. Third step, shade above or below. Well, now we can look at it as above or below, right? Because we've got a horizontal line, so there's clearly an above and a below. Less than says shade below. All right. So if we put it all together, our graph's going to look like this. So we knew the line y equals -7 was a horizontal line at -7 through the y-axis. We knew it was dashed because of the less than symbol. And we knew we shaded below because of the less than symbol. Okay, so actually graphing these horizontal vertical boundary lines are pretty simple. Okay, I think I did one more here. This one is x is greater than -7. Okay, it still means the same thing. Our x graph is going to be a vertical line that goes through the x-axis at -7. Okay, x equals a number is always a vertical line. Okay, so it's undefined slope. There is no y-intercept. Okay, should it be dashed or solid? Well, greater than means it should be dashed. Should we shade above or below? Well, this is another one of them cases, like we said, that our line's vertical, so there is no above or below, right? But I want to shade the side of x values that are greater than 7. So that should be to the right of my vertical line. Those are where the numbers are greater than -7. Okay, so hopefully that makes sense when you think of it that way. So here's my graph. You know, x equals -7 is a vertical line going through the x-axis -7. It's dashed because of the greater than symbol. We're going to shade to the right because of the greater than symbol. All these order pairs over here are my solutions. To the left are not solutions. So that's how we handle a vertical horizontal boundary line. Okay. The last concept I want to go over is let's flip this whole thing around. Let's give you a graph of a linear inequality and you write the linear equality that's represented by this graph. Okay, so our process is really going to stay the same. Our first step is we need to come up with a boundary line. So what equation represents the boundary line? Really, what I need here is what's the slope and the y-intercept of this line. Okay, well they clearly mark two ordered pairs, right? I got the ordered pair -4, -5, and 0, -2. So I could use these two to find the slope. Now I could just go rise over run, which on this graph is real easy, and you're probably all going to do it that way, right? Rise at 3, run a 4. Or I can do it this way. Difference in the y's, -2 minus -5. Difference in the x's, 0 minus -4. Plus positive, the top is 3. Minus a negative becomes plus positive, right? So it's 4. So there we go. Slope is 3/4. Same thing we did if we counted, right? Now, the y-intercept, we get lucky because they actually label it for us. If they wouldn't have gave us a y-intercept, we'd have had a lot more work to do here. But they give it to us. So the y-intercept is -2. So I have what I need to write the equation. All right. I got my slope 3/4. I got my y-intercept -2. Now, is that boundary line dashed or solid? Well, the boundary line is solid. So if it's solid, that means it's either going to be less than or equal to or greater than or equal to, right? The greater than less than are out. It's got to have an equal to on it because it's solid. Did they shade above or below? Well, they shaded above. Since they shaded above, we know that of these two choices, it's got to be the greater than or equal to. All right. So now I have everything I need to write my equation. I got my slope, I got my y-intercept, I got the symbol that I need. So the inequality to represent this line is y greater than or equal to 3/4 x minus 2. Y equals mx plus b, if you will. Getting that symbol was the key. Okay, so that's how we do it, working backwards. It's the same three steps. We're just kind of filling the information in backwards. All right, another one. Here's our line. Here's our graph of our linear inequality. So what's first? We got to find the slope and the y-intercept. So we got two ordered pairs. We got the ordered pair 5, 2, and 0, 6. So I could use those two to find my slope using the slope formula. Difference in the y's over difference in x's. Okay, 6 minus 2, 0 minus 5, 4 over negative 5, which is negative 4/5. Could have went rise of 4, run of 5, and got the same answer. Okay. Again, the y-intercept, they give it to us, so you might as well use it. The line here is crossing the y-axis at 6. They label it, so we got that. So I have the two things I need to write my equation: slope, y-intercept. Now we need the rest of the information. So we're asking now, is that boundary line dashed or solid? Well, it's dashed. Since it's dashed, that means they either used greater than, excuse me, this is less than or the greater than symbol. It's one of these two. It doesn't have the equal to. Step 3, did they shade above or below? Well, in this case, they clearly shaded below. So from these two choices, it's got to be less than. Less than will give it dashed, less than will make it shade below. So that's my guy right there. So now I just take my information, my slope, my intercept, and my inequality symbol, and I write the inequality to represent this equation. Y is less than negative 4/5 x plus 6. Okay, pretty straightforward there. All right, last one. It's one like we kind of introduced today. So you can see that I have a horizontal boundary line. Okay, so now I don't really have to find the slope and the y-intercept because I know how to write an equation for a horizontal boundary line. It's going to be y equals negative 4. That line right there is y equals negative 4. Okay, so I know that's what it's going to look like. All I need to do is figure out now, what do I put in here for this equal sign? So first question, was the boundary line dashed or solid? Well, it was solid, so it's either going to be less than or equal to or greater than or equal to. Did they shade above or below? Well, they shaded above, so I know it's got to be the greater than or equal to sign. The greater than or equal to sign will make this solid and it will shade above, so that's what I need. So I'm going to take my boundary line and I'm going to replace that equal sign with greater than or equal to, and it creates this graph. So those are the steps, and those are the types of questions you're going to get tonight. All right. So it's building on the ideas we had yesterday, adding a little bit to it. Make sure you're writing things out, show process, show work, and I'll let you guys have at it.